All right, folks. So today we're going to take a more in-depth look at the MX-P50M. This is an HF power amplifier. It's capable of putting out around 45 watts with around 5 watts in. And as you adjust your input wattage, it will adjust the output wattage here. And I typically don't drive this at 45. It tends to get a little warm. But we did a video about a week or two ago, and what we saw was that there were some harmonics that did not comply with regulations on the 20-meter band. So what I want to do today is that actually when you set the filter, and it's not powered in, so you're not seeing it right now, this is a filter setting for 30 through 17. So what I want to do is I want to test 30 meters, I want to test 20 meters and 17 meters and see if we see the same problem. And what I suspect is that we have a bad low-pass filter in here, and we'll take a little bit of that throughout the test that we're going to do. In order to test this device, we are going to use this ICOM IC705 to generate a signal, amplify it here, then, hold on one second. We're going to take that signal and then we're going to run it through our big ass attenuator. This is a 40 dB 100 watt attenuator, so it should be able to handle the signal just fine. And last time we put this into a Siglent spectrum analyzer, but because I don't feel like getting all this stuff out on my desk, we're going to actually use the TinySA. And I have computer-based software that allows us to see the screen, so it'll be easy for everybody to see. So let me get this all set up and we'll start testing. Okay, for the sake of keeping this simple, what we have here is a Bioenno 12 amp hour, 12 volt battery. And that battery is coming in here and it is powering our amplifier. So our amplifier has got a keying cable that comes out and goes into the side of the 705 right here. The 705 is being powered off of its own internal battery, or battery that clips on the back of it, whatever you want to call that. We're going to inject a signal from here, and we are going to control our power output here. We are currently at 25%, give or take. Now, I'm not using an SWR power meter because I didn't feel like setting all that stuff up. I did in the previous video, which will be linked below if you want to see some of the test methods and standards and all that kind of stuff. The signal comes out of the antenna port on the 705 and it goes into the signal port on the back of the amplifier, and then the output of the amplifier comes out here. It runs through about, I don't know, 5 feet, something like that, of coaxial cable into our big ass attenuator. And then from the big ass attenuator, it comes out and goes into the RF port here on the TinySA Ultra. This is the newer, larger, bigger screen version. And here we have some software that we can use to see what's going on the TinySA. So that said, let's go ahead and get started. We'll start with 17, go up to 20, and then go up to 30 meter bands. All right, so we're set up to test 17 meter band, and here you can see the 705 is set with a frequency of 18.150 megahertz. What we need to do now is go over to the TinySA, and there's a couple of things that we need to account for. So the first thing I'm going to do is activate the menu, and then I'm going to go to level, and then I'm going to set our external gain to negative 40 dB, because that is what we have in terms of our attenuator. Next thing I'm going to do is I'm going to go back into our main menu and I'm going to go down to measure and I'm going to pick harmonic. This is the correct way to measure harmonics on a TinySA. And so I'm going to go here and go 18.150 megahertz. And what this will do is this will set up our span. It'll set up our markers when we key up and see what's going on. So what I'm going to do now is I am going to key up and we're going to see where we fall on the TinySA. And I got to tell you, that's a little peculiar. I would have expected to see something a little different. There we go. There we go. And what we can see there is our initial marker is around 4.9 dB, and then the delta for marker number 2 is 62 dB down. Marker number 3, the delta for that is negative 43, which is below the threshold that we need there. And then you can see marker 7 way down the line is negative 64 dB. So this looks to me like we passed, or that we're doing okay on the 17 meter band. Let's go ahead and jump up to 20 meters. Let me get that set up. Okay, we have our radio set to 14,300. This is what we did last time. So what I want to do here is I want to go to measure. Oh, I want to go to measure, and I'm going to turn it off, and I'm going to go back. I'm going to hit measure, and I'm going to pick harmonic again. I'm going to pick 14.3 megahertz to set this for our test. There we go, and now I'm going to key up, and we're going to see what we see. So you can see our first marker. It's a little bit off. It's at 14.2. And then the second marker that we have is negative 59. Does that look about right? Our third marker is negative 40. So when we talked about this last time, we wanted to be at least 43 dB below our fundamental, and we are not with that marker 3. And this just reinforces what we saw on the signaling, and that this thing does have a little bit of an issue or challenge here. Now, if you look at marker 3, it's reading 28.5 megahertz, so that would be the 10 meter band. And that would tell me that we do have a problem here with our filtering, and the low pass filtering is not working correctly. So let me go ahead and turn this off, and then what we will do is we will come back and we will test 30 meters. Okay, we're back, and we are on 10.1 megahertz, or a 30 meter band. So let me go in here, and let me go to measure, and I'm going to turn this off. I'm going to come back here, and I'm going to go to measure, and then I am going to go for harmonics. And I'm going to type in 10.1 megahertz, and that is going to configure the TinySA for us. And then now we're going to key up and see what we see here. Okay, and what we can see here is that when we take a look at our primary marker, it is at 5.3 dB. When we take a look at marker number 2, it's 47.2, so that's right on the cusp. But when we take a look at marker 3, it's at negative 39 dB, and then marker 5 is at negative 44. So basically what we're seeing here is that this is not compliant on the 30 meter or the 20 meter band. 17 looked like it was okay. So what I'm going to do now is I'm actually going to put this off and put it in bypass mode and key up and see what we see. Because some folks were wondering if it was the amplifier or if it was the radio. And so here we are in 30 meters, and when I take a look at this, it looks fine to me. Let's go over and take a look at the 20, because folks wanted to see the same thing after the last video. And we are going to key up. Now I know I didn't adjust the TinySA, but that's all right. And then when I do this, it appears that we are just fine. So I think the problem is the low pass filter. So what I want to do is I'm going to break this open in a different video, and we're going to locate the filter that's problematic. We're going to remove that and test the components and see what we can do to correct it. Anyhow, thanks for watching. If you have any questions, comments, suggestions, or recommendations, go ahead and post them below, and I'll do my best to respond. Thanks.